All right, so true or false, all parallelograms are quadrilaterals. True. What does quadrilateral mean? 4 sides. All parallelograms have 4 sides. Absolutely correct. Number 2, no rhombus is a parallelogram. False. If you go back and look at our definition for a rhombus, it starts off with a parallelogram that has 4 congruent sides. So all rhombi are parallelograms. What about number 3? All squares are rhombi. This is true. Well, that's what I'm getting ready to explain. What's the definition of a rhombus? It's a parallelogram with 4 equal sides, 4 congruent sides. Is a square a parallelogram? Yes. Does it have 4 equal sides? Then it's a rhombus. It has 4 congruent angles, 4 right angles, which a rhombus doesn't have to have, but it can. Some rectangles are squares. Some rectangles are squares. True or false? True. In order to be a rectangle, it's a parallelogram that has 4 right angles. If that shape that is a parallelogram and has 4 right angles happens to have 4 congruent sides, then it would also be a square. Some rhombi are rectangles. True. Some rhombi could have 4 right angles. A rhombus has to have 4 congruent sides and it's a parallelogram. If that rhombus happens to have 4 right angles, then it would meet the definition of a rectangle. So not all rhombi are rectangles, but some of them are. All right. We are going to be in your notes on page number 10. And we are going to finish Module 7 today. We're going to do one more problem with a trapezoid, and then we're going to talk about our very last quadrilateral, the kite. So on number 6, page 10, number 6, the first thing I know about this shape is that it is an isosceles trapezoid. What did we learn yesterday about an isosceles trapezoid? 2 sides are the same. Which 2 sides? Like if you're looking here at RSTU, which 2 sides would be the sides that are the same size, congruent? Which one? The legs. How do I know which ones are the legs? You're absolutely right. Yep, it's the ones that are slanted. So RS and TU, those would be my congruent sides because it's isosceles. And then what else do we know about an isosceles trapezoid? And this is true for all trapezoids. I know the legs are congruent, and I know what? They do have midpoints. The bases are parallel. We'll mark our midpoints here in just a moment. Where are the bases on the picture? Top and bottom, ST and RU. So those would be my parallel sides. Those are the bases. All right, so they give me a little bit more information here. It says it has a mid-segment, HK. So H is the midpoint of one leg, and K is the midpoint of the other leg. They didn't tell me which side H is the midpoint for, so I get to choose. So I'm going to make H the midpoint of RS here. So I'm taking this side and I'm cutting it into 2 equal parts. So we're going to make this one H. And so then over here on TU, that's where I would have K, and it's cutting this side into 2 equal parts. Since it was an isosceles trapezoid to begin with, I took two legs that were the same size and I cut them both in half. So now I have four little segments that are all congruent. And we're going to go ahead and draw in this mid segment where we connect the two midpoints together. So there's my mid segment HK. That's all the information that they give me in bold, but then I get to part A and they give me a little bit more. What do they tell me in part A that I could add to my picture? Yep, so I'm going to add that to my picture over here. HK is 6x minus 13. What else do they tell me? RU is 5x plus 24, so that would be my bottom base. 5x plus 24. And what else? ST is 48. What do they want me to find in part A? X and the measurement of RU. Well, where's X in my picture? Yep. It's on the mid segment, and it's down here on RU, which is one of my bases. Since X is part of my mid segment and it's part of my base, I need an equation that has both the mid segment and the base in it. So we're going to use our mid segment formula that we learned yesterday. The mid segment of a trapezoid is equal to what? Yes. The mid segment is equal to 1/2 and then parentheses. What does B1 stand for? Base 1. What about B2? Base 2. What's base 1 on our picture? 48. Or you could say it's what? It could be 5x plus 24. It doesn't matter which one you call base 1 and which one you call base 2. But you guys indicated that you want to call the top one base 1, which is perfectly fine. So now I'm going to come and substitute in place of the word mid segment, I can replace that with what? Minus 13, yes. Right, and that is equal to 1/2. And then I need to replace the B1 with what? 48. Yes, plus 5x plus 24. All right, now I have an equation that I can use to find x. Very first thing I want to do is deal with this 1/2 out front. I could distribute it, but then I'm going to have some decimals or fractions. I don't really want to deal with either one of those. What'd you say? Multiply by 2. Why by 2? Because it's the denominator. Multiplication undoes division, and my fraction means division. We always multiply by the bottom of the fraction, so we're multiplying both sides by 2. And if you do it to one side, you got to do it to the other side. So on the left, I'm going to take this 2, and we're going to distribute it to both of these pieces here. 2 times 6x gives me 12x. What's 2 times 13? 26. So 12x minus 26 is equal to, and now I get over to the right-hand side. The 2 that we multiplied by cancels with the denominator. I still technically have something to distribute. This 1 gets distributed inside those parentheses. But what happens when I multiply things by 1? Stays the same. So I have 48 plus 5x plus 24. And over there on the right, I've got these two like terms that I need to combine together. So I have 12x minus 26 equals 5x plus what? 72. Oh, did you say 3? I thought you said 72. Which one is it, 72 or 73? 72, okay. All right, so I got to bring my work over here because I ran out of room. 12x minus 26 equals 5x plus 72. What do I want to do now? Combine like terms. I want to get my x's on the same side, right? So how do I get my x's to the same side? Subtract. What are we subtracting? Yep. Yes, we're going to subtract the 5x from both sides, so I'm doing 12x minus 5x. What is 12x minus 5x? 7x. So I have 7x minus 26 equals 72. And now what? Add 26 to both sides. What is 72 plus 26? 98. So 7x equals 98. X equals 14. You are absolutely correct. We're going to divide both sides by 7. And 98 divided by 7 is 14. All right, so there's part of what they wanted me to find. And how do I do the other part? How do I find RU? Yes. Yes, that's absolutely correct. RU is equal to 5 times 14 plus 24. What is 5 times 14? So 70 plus 24 would give me what? 94. So RU is 94. For part B, they're giving me more information now that I can add to my picture. It says that the measurement of angle S is 117 degrees. So I'm going to come up here to angle S. That is 117 degrees. And then they tell me that the measurement of angle R is 3A plus 15 degrees. Well, here's angle R. 3A plus 15 degrees. They want me to find A. They want me to find the measure of angle T. And they want me to find the measure of angle U. Which one do you guys want to do first? T is easy. Why is T easy? Yes, S and T are both touching base 1, so these are base angles. And the base angles on a trapezoid are congruent, so angle T would also be 117 degrees. All right, which one do you want to do next? A or the measurement of angle U? A, sounds good. All right, so to find A, let's see, I've got 3 angles here. Can anybody find a relationship between angle R and one of these two? T? No, because to be alternate interior, they have to touch 2 different parallel lines, but then they have to touch the same transversal. What'd you say? So R and S. What do we know about angles R and S? They add up to 180. So we call these non-base angles because they don't both touch the same base. And non-base angles are supplementary. They add up to 180, yes. If you remember your parallel line stuff from first semester, here's my 2 parallel lines, and they're on the same side of the parallel lines. So those would be consecutive interior angles, which are supplementary angles. All right, so I have the measure of angle S plus the measure of angle R equals 180 because they're supplementary. In the place of angle S, I can put 117 degrees. What are we going to put in the place of R? 3A plus 15. So I have 117 plus 3A plus 15 equals 180. What do I do now? We just did some substitution. Add 117 to what? 15. Those are like terms. They're both constants. What is 117 plus 15? 132. So 3a plus 132 equals 180. And now I need to subtract 132 from both sides. So I'm going to do 180 minus 132. What is 180 minus 132? 48. Last thing I need to do. Divide. So I have 48 divided by 3, and John, that is how much? 16. So A is 16. All right, we found two of the things they asked us to find. We found A, we found the measurement of angle T, and I still need to find what? U. I know of at least two ways that I can find the measurement of angle U. You got an idea? Yes.
Would you do R if you fill in A with 60?
Yes, you can. So there's the two ways that I know of to find this angle. T and U are non-base angles. So that means they are supplementary. So I can do 180 minus 117, or I know that angles R and U are congruent. So I can take my value of A, which is 16, I can sub it in for A here, and I can find the measurement of angle U that way. Let's do it both ways, because I want us to see that it doesn't matter which method we choose here. So angle R is congruent to angle U. So the measurement of angle R is equal to the measurement of angle U. So that's 3A plus 15 equals the measurement of angle U. We're going to put 16 in the place of A. What is 3 times 16? 48. So then I have 48 plus 15, which gives me what? 63. So 63 degrees for the measurement of angle U. Let's check using the other method. We can do 180 degrees minus 117 degrees. And it also comes out to be 63 degrees. So I get the same answer whether I substitute into a congruent angle or whether I use my supplementary angles and subtract it from 180. Very nice work on that problem. All right, last new shape, last new quadrilateral in this entire module. We're going to talk about a kite. A kite, what'd you say? I like kites too. Just got a new kite recently. A kite is a quadrilateral with two pairs of adjacent congruent sides. Notice they're congruent, not parallel. What does adjacent mean? Next to or touching, yes. So these are the sides that are touching each other. So that's our definition of a kite. And now we're going to get into the properties of the sides, the diagonals, and the angles. For the sides, I'm literally just going to repeat the definition. I have two pairs of adjacent congruent sides. So when I'm looking at this kite over here on the right-hand side, the top two sides, these top two slanted sides, the smaller ones, are congruent to each other. And then the bottom two sides, the longer two sides, are congruent to each other. For my diagonals, one diagonal is bisected. This will be my shorter diagonal. And my diagonals are perpendicular. What does perpendicular mean again? They cross each other, and what happens when they're crossing each other? 90 degrees, yes. It forms right angles. So let's go ahead and draw in the diagonals here. So I'm going to connect opposite corners. So I'm going to connect left to right, and I'm going to connect top to bottom. Which one of those diagonals is the shorter one? The left to right or the top to bottom one? Left to right. That's the one that's being bisected. That's the one that's being cut in half. And if you look at it, it makes sense because my other diagonal, the top piece of this is obviously much shorter than the bottom piece, so those wouldn't be the congruent parts. And then right here where these diagonals are crossing each other, it's forming 4 right angles. And then we have our angles. There is one pair of opposite congruent angles. The opposite angles that are congruent are going to be the two angles that are connected by the shorter diagonal. So this angle right here and this angle right here. The top and the bottom are not congruent, but the left and the right are. It won't always be the left and the right because we could take a kite shape and we could turn it. Think about how a kite kind of flies through the air. It's not always up and down like this. But it's going to be the cross angles there. All right. So far, so good? Let's solve some problems with kites, and then that'll wrap us up. So down at the bottom, we've got 8, 9, and 10. In problem number 8, it tells me that KLMN is a kite, and they want me to find the measure of angle N. I know a kite has one pair of opposite congruent angles. Is that going to be K and M as my congruent angles? N and L. K and M are not congruent because K is 71 and M is 52. So these are my congruent angles here. And I know that when I add all 4 of those angles together, measure of angle K plus the measure of angle M plus the measure of angle N plus the measure of angle L. All four of those angles are going to add up to how much every time? 360 degrees. How do you know that it's 360? A square is 360. I heard an idea here, Layla. What were you saying? Nope. Okay. How do we know it has to be 360? Yes. It's a quadrilateral. It has 4 angles and 4 sides. Does anybody remember the formula that we had to figure out how many degrees all the angles add up to? Sides minus 2, so n minus 2 times 180. So this is a 4-sided shape, so we do 4 minus 2 times 180, and that's how we get this 360 degrees. So all of my 4-sided shapes will have an interior angle sum of 360 degrees. I know how big angle K is, because it told me. Angle K is 71, so I can put that in for angle K, 71 degrees. How big is angle M? 52 degrees. And then I also need to add angles N and L, but I don't know how big they are. What can I call angle N if I don't know how big it is? X. So what could I call angle L? I can call that X as well. Why can I give it the same exact letter name? They're equal. They're exactly the same size. If they weren't congruent, then I would have to call one X and the other one Y. But because they're congruent, I can give them the same variable. Well, it is going to be 2x, but each angle is just x. All right, so now I have my equation set up and my substitutions made. I need to combine my like terms together. So I'm going to add the 71 and the 52 together and get how much? How much? 123 degrees. And then I need to combine my x's together. X plus x, yep, would give me 2x. So 123 degrees plus 2x equals 360 degrees. What do I do now? Yep, we're going to subtract 123 degrees from both sides. 237, thank you. So 2x is equal to 237 degrees. Last thing I need to do to isolate x? Divide both sides by 2. And so x would come out to be how much? 118.5 degrees. We had x representing the measurement of angle N, so that means that angle N is 118.5 degrees. 118 and then the fraction 1/2, that would still be correct. Yes. Let's do number 9 together, and then I'm going to have you guys do number 10 on your own to practice this. We want to find the measurement of angle F. Well, here's angle F. So what about angle H? It'd be the same. It'd be congruent. I don't know how big either one of those is, so what can I call them? X. I can call them both X. And then I'm going to add all 4 of those angles together. So I'm going to add X plus 128 degrees plus 72 degrees. And I'm going to set that equal to how much? 360. So now I combine my like terms together. I've got 2 x's that need combining. And then 128 plus 72. X plus x gives me 2x. What is 128 plus 72? 200. So 2x plus 200 degrees equals 360 degrees. Now what? Subtract 200 from both sides. What is 360 minus 200? 160. So 2x is 160 degrees. And then I divide both sides by 2. What is 160 divided by 2? 80. So x is 80 degrees. And we had x representing the measurement of angle F. So this would be 80 degrees. All right. Take about 2 minutes to do number 10 on your own. Yes. Yes, that is absolutely correct. Check your subtraction here. Does anybody have an answer that they are comfortable sharing? Not 63. 113. Let's go through this one quickly so that everybody understands where this is coming from. So we're looking for the measurement of angle C. We're going to call that x. Angle A is congruent to it. So I add x plus 102 plus 32. And I set that equal to 360. So then I combine my like terms together. X plus x gives me 2x. 102 plus 32 is 134. And then I subtract 134 degrees from both sides. So I get 2x is equal to 226 degrees. And then I divide both sides by 2, and that's how I get 113 degrees. All right, there's one more thing that I want to do with kites. It's on page 11. Number 11 on page 11. There we go. What a coincidence. Is 1151, page 11, problem number 11. If only it was 1111, but you guys were still at lunch then. All right, so this quadrilateral is a kite, which means I know I have two pairs of adjacent congruent sides. They want me to find AD, and then I need to find the perimeter of this kite. How do you find the perimeter of something? Yes, we're going to add all the sides. Let's start off by finding the length of segment AD. Here's segment AD. This is what we're looking for. I have no idea how big that is, but they did give me some measurements in there. What measurements do I know of that are near the one that I'm looking for? 24, which would be ED, and what else?
AE.
AE, which is 12. Notice when I went over those sides, it created this triangle right here. What type of triangle is that? It's a right triangle. Why is it a right triangle? What's happening right here? 4 right angles. Remember, those diagonals are perpendicular to each other. So I have a right triangle here. I know 2 of the sides of this right triangle. What can I use to find missing sides in right triangles? Pythagorean theorem, yes. So we can do a squared plus b squared is equal to c squared. The segment that we're looking for, AD, would I put that in for A, B, or C? C. Because the side that I'm looking for here is the hypotenuse. So in the place of C, I'm going to put AD. So I have AD squared over on the right-hand side. So what do I put in for A and B? 12 and 24. 12 goes in for one of them. 24 goes in for the other. It does not matter which is which. So I have 12 squared plus 24 squared equals AD squared. What is 12 squared? 144 plus, what is 24 squared? 576. So 144 plus 576, what does that give me? 720 is equal to AD squared. And then what do I do? Square root it. If you do it to one side, you got to do it to the other side. So on the right, the squared and the square root cancel each other out. 12 radical 5. 26 point, let's take it out to 3 decimal places. 832. Or 33, depending on how you round it. Let's go with 33. You can put 0.832, that's fine. All right, so we found the length of segment AD. This is 12 radical 5, or 26.833 in decimal form. So I'm going to go add that to my picture. This is 26.833. Now we need to find the perimeter. Do I have another side that's that same size? It depends on what it says. It depends on the question. CD, 26.833. Do I have enough information to find the perimeter of this? Can I add all the sides? I got to find either A, B, or B, C. They're congruent, so I just need to find one of them. Let's go ahead and do A, B. It's the exact same process, exact same answer if you do B, C. All right, so how am I going to find that? A squared. And then what? Just A squared plus B squared equals C squared. There we go. A squared plus B squared equals C squared. Side AB is which piece there? A, B, or C? C. Because we are looking for the hypotenuse. So what do I put in for A and B then? 12 and 6. 6 is this side. 12 is this side down here that they had in common. So I have 12 squared plus 6 squared equals AB squared. We already did 12 squared. That was 144. What is 6 squared? 36 equals AB squared. What is 144 plus 36? 180. So I have 180 is equal to AB squared so 180 plus 180 plus 26.833. Is that right?
That's about 13.4.
What do I need to do to get the 16 point whatever?
I said 13.
Oh, it's 13. I apologize. There we go. We're going to square root both sides. And what is the square root of 180? 6 square root of 5, or what would that be in its decimal form? Sorry, one more time. You said 13.416. So I'm going to go add that to my picture. I'm going to add the decimal form one so that it's easier for me to add. Although we could add the one with radicals. To add radicals together, you only add the numbers in front, the whole numbers. You don't add the part that's underneath the radical, and it has to be the same number that's under the radical in both spots. All right, now we are ready to find the perimeter. Now I know all four sides. So I'm going to add 26.833 plus another 26.833 plus 13.416 plus another 13.416. Hold on just a second before you give me the answer, because that's an awful lot to stick in my calculator like that. I have 2 of these, and I have 2 of these. What would be an easier way for me to put this into my calculator? Yes. You can just put them in as 26.833 plus 26.833 plus whatever. Or you can multiply them by 2, and it's that much less that you have to type into your calculator then. 13.416. What do you get no matter which way you put it into your calculator? 80.498. All right, we're going to do another one that's just like this. And then you guys are going to do the last one on your own, and I'll put the answer up for that. All right, first thing they want me to find is CD. Notice there's a typo down here. This should say CD, not AD. CD is right here. How are we going to find that length? Pythagorean theorem. A squared. On these, when I know the diagonals on the inside, when I know those sizes, and I'm looking for the outside pieces, yes, I'm going to use Pythagorean theorem every time. The part that I'm looking for, CD, is the hypotenuse. So what are we squaring and adding together? 8 and 5. This right here, BT, is the same size as DT, so this would be 5 over here. So 8 squared plus 5 squared. What is 8 squared? 64. And 5 squared? 25. What do I get when I add those two together? 89. And then I need to do what? Square root it. If you do it to one side, you got to do it to the other side. On the right, the squared and the square root cancel. Let's take this one out to 3 decimal places. What is the square root of 189? 9.434 is equal to segment CD. What else do they want me to do here? The perimeter. Well, I know 2 of the sides. I just found it. 9.434 What other side is 9.434? BC. To find the perimeter, we're going to have to find the length of either segment BA or DA. Let's find DA. So Pythagorean theorem again. A squared plus B squared equals C squared. What am I squaring and adding together? 12 and 5. 12 squared plus 5 squared equals AD squared. Yep. What is 12 squared? 144. Plus 5 squared? Plus 25. What is 144 plus 25? 169. And then what do I need to do? Square root it. If you do it to one side, got to do it to the other side. On the right, the squared and the square root cancel out. What is the square root of 169? 13. This one came out to a nice, pretty whole number. So I'm going to come over here and add that to my picture. 13 and 13. And then we're going to find the perimeter. I have two sides that are both 13. So I would have 2 times 13. Plus, and then I have two sides that are 9.434. And you said we get what when we add all the sides together? 44.868. All right, I would like you guys to do the last problem, number 13, on your own. Take about, let's do 3 minutes, and then I'll put the answer up for that. Yeah, you're going to find ZY. It got misprinted on the answer line there. So you want to do what the problem is actually saying. You're going to find ZY. ZY, yep. Right here. That is exactly correct. Nice work.
That's what you said, right?
Yes. I'm coming. You done? Yep, there you go.
Can I
In just a little bit. On this one, you can go to the third, or since that last number is a 0, you can just go there. Either one is fine. Either one is appropriate. I want you guys to go out to 3 decimal places unless that third decimal place is a 0. Yes. Good questions. You hit the second key, and then you push the squared key. You're welcome.
This will look
these two sides don't make a triangle together. That's these two pieces. When you're finding so when you're finding XY right here, that would be these two sides. So you want this and this. So you have to replace that with this. Yes. What do you guys get for ZY? 10.440. If there's a 0 in that third spot, I'm okay if you just put 2 down. That's totally fine. Or you can write them all 3 down. That's fine. What is the perimeter? 30.88. Absolutely correct. Does anybody need to see me work through that? Yes, okay. So to find ZY, this side right here, this segment is congruent with this segment, so this would be 3. So we would do 3 squared plus 10 squared is equal to ZY squared. 3 squared is 9. 10 squared is 100. So we would have 109 is equal to ZY squared. And then when you square root both sides, that's where we get the 10.44 from. So 10.440 when you take that one out to 3 decimal places. So I have 10.44 here and 10.44 here. Then we need to find either XW or ZW. So that would be 3 squared plus 4 squared is equal to XW squared. 3 squared is 9, 4 squared is 16. When I add 9 and 16 together, I get 25. And then we do the square root of both sides, and the square root of 25 is 5. So I would have 5 for those two sides. And then to do the perimeter, we have 2 times 10.44, because we have 2 sides that are 10.44, plus my 2 sides that are both 5. And that's how we get 30.88. Right. Very nice work today on the notes, guys. The homework number 6 is due tomorrow. That is the last homework of this module. Tomorrow, after we grade and correct your homework, we're going to begin reviewing for your test, which is next week. We're going to do the very last page in your notes, page number 12, to help us review. That's just going to help us make connections between all the different types of quadrilaterals we've studied.